Hello girls, I hope you're staying safe at home. To continue with the water chapter, we move on to the next section and we are going to talk about solutions today. Okay, now you all know what solutions are. So solutions are actually mixtures of solid in water. So to define solution, you will define it as a homogeneous mixture. Homogeneous means having the same composition throughout. Okay, so it is a homogeneous mixture of two or more components whose composition may be gradually changed by changing the relative amounts of the components. That is, if you take more solvent and less solute, or less solvent and more solute. Okay, so that time what will happen? The composition can be changed. So what is a solution? It is a mixture of solute, that is the solid, or it may be a liquid, or it may be a gas with the solvent. Solvent is the substance which dissolves the solute. So in this case, if we take a solute, for example, say salt, and we put it in water, so salt is the solute and solvent is the water. So what do we get? We get a salt solution. Okay, so the medium of this solution, that is the water in this case, allows one or more components to dissolve in it to form a solution. So that is known as the solvent. Okay, and the substance that dissolves in the solvent to form a solution is known as the solute. So a solution may be made up of two components. So that type of solution is known as binary solution. Sometimes they may be made up of three components. So that type of solution is known as ternary solution. Or if they are made up of four components, then they are known as quaternary solutions. Okay, so in your syllabus, there is only binary solution. Okay, for example, we take some salt crystals. Now remember children, in chemistry when we talk about salts, we are not talking only about the common salt. It can be anything. It can be copper sulfate, it can be sodium chloride. Okay, so there are so many different types of salts. Okay, so when salt crystals dissolve in water to form saline water, the salt is the solute, the solid. The water in which the salt dissolves is the solvent, and the saline water, that is salty water, is the solution. So if the components are existing in different physical states, then the solvent is that component which exists in the same phase or state as the final solution. So what is the final? If you take the salt and you put it in water, okay, so solvent is the component. It will remain as the liquid in the final solution. For example, the example is given again. If sugar is dissolved in water, the final solution is a liquid solution. Why? Because the solvent was a liquid. You dissolved sugar, which is a solid. So water is the liquid, is the solvent, and sugar is the solute. So if the two substances are in the same state, okay, supposing you take liquid. Okay, now supposing you have, say, orange squash and you are supposed to make orange juice. You take a little bit of the squash, which is liquid, and you take lots of water. Okay, so you are dissolving with solvent. The orange squash is the solute and the solvent is water, because you have taken water more. Understood? So when water is more and the orange squash is also liquid, it is less. So whatever you are taking in excess is the solvent. So you can have a solution by mixing a liquid with another liquid. I just gave you an example, orange squash and water, but here another example is given, water and alcohol. A solid with a liquid, we already talked about sugar solution or salt solution. Okay, and a liquid with a gas, that is soda water. Carbon dioxide is put in water, and a solid with another solid, example, alloys. Okay, now a homogeneous solution, I already told you homogeneous means having the same composition throughout, of a solid into another solid. When two solids are mixed, it is called an alloy, and that is a solid solution. Okay, so you must have heard about many different types of metal alloys, and they are solid solutions. The gold used in making jewelry in a solid solution contains gold, and small quantities of copper or silver to make the gold a little bit hard. So gold is the solvent and copper or silver is the solute. So brass is an alloy. It is made up of 70% copper and 30% zinc. So what is more? Copper is more. That means copper is the solvent and zinc is less, so zinc is the solute. A solution in which the size of the solute particles is about 10 to the power minus 10. That is 1 divided by 10 to the power 10. That is very, very, very small particles of the solute are there. That type of a solution is known as a true solution. Now, in a true solution, the solute particles are so small. It is as small as the solvent molecules, so you cannot distinguish it even under a microscope. You cannot say which one is the solute and which one is the solvent. So that is a true solution. When we talk about solution, actually we always mean a true solution. Now, the characteristics of true solution is important, children. It is a homogeneous mixture. Again, I'm telling you, homogeneous means having the same composition throughout. Like if you take, say, a sugar solution and you drink it, or that time I gave you an example of making orange juice. You put squash and then you put water, and when you drink it, the first sip and the last sip taste the same. It has the same taste throughout. So it is homogeneous, having the same composition throughout. And as already mentioned, the solute particles are very small, about 10 to the power of minus 10 meter. It is very clear and transparent. It does not scatter light, means light will pass right through it. It is that transparent, and we cannot separate the components by filtration because they are mixed together. The solute particles in a solution do not settle down because it has mixed, so it is not like solid inside, so it will not settle down. Now please remember, children, water is the most common solvent. I had already told you it is known as a universal solvent. So it is a solution produced by dissolving a substance in water, and it is known as aqueous solution. Aqueous means dissolved in water. Okay, but it is not the only solvent. Though it is a universal solvent, it can dissolve almost any substances found on the surface of the earth, but it is not the only solvent. You have other solvents like alcohol, petrol, ether, benzene, carbon disulfide, liquid ammonia. These are non-aqueous liquid solvents. Non-aqueous means it is not water. Okay, please remember the names of these non-aqueous liquid solvents. The solution made in these liquids are known as non-aqueous solution. Okay, so when the solvent is alcohol, when you dissolve something in alcohol, the solution is called a tincture. Okay, tincture of iodine is a solution of iodine in alcohol. Now, dilute solution and concentrated solution. Dilute solution means where the amount of solute is rather less compared to the mass of the solvent. That means there is lots of solvent and very less solute. So that is known as a dilute solution. And concentrated solution means a solution in which the amount of solute is relatively more for a given mass of solvent. That is, solvent is less and there is lots of solute. Okay, so that is a concentrated solution. Now moving on to saturated solution, a solution that cannot dissolve any more of the solute at a given temperature is called a saturated solution. Saturated means, okay, enough. I cannot take in any more of the solute. Supposing you take a glass of water and you take 1 spoon of sugar, you stir it, it will dissolve, again another spoon, again another spoon. You will see at a certain point, you take a spoonful or even 1 crystal of sugar, you put it in, that 1 crystal will not dissolve because all the intermolecular space of the water has been full with the solute particles. So it is houseful, you can say. Okay, there is no space even for 1 molecule of the solute. So How do we prepare a saturated solution? We take 100 grams of distilled water in a beaker and we add 1 gram of niter and stir it with a glass rod till the niter dissolves. Niter is potassium nitrate. Okay, please do not forget. Now again we take 1 more gram of niter and stir it. Again it will dissolve. So we keep on adding 1 gram of niter at a time and keep on stirring it after we add it. And you will see a stage will come when no more of the niter will dissolve at that temperature, no matter how long it is left there or how vigorously, how hard you stir it. That means the solution cannot take in any more of the niter. That means the solution is now saturated with niter at that temperature. So this is the saturated solution of niter in water, because after that it cannot dissolve any more of the solute without changing the temperature. The temperature is kept constant, children. So a solution is a homogeneous mixture of a solute in a solvent. Its composition may vary till a saturated solution is obtained at a particular temperature. So until the saturated solution is obtained, a solution is always a homogeneous mixture, but what will happen? The amount of solute will keep on increasing. That means the composition will keep on changing. Now, effect of cooling on a saturated solution. Okay. Now, the solubility of a solid usually decreases with fall in temperature. Okay, that means the warmer is the solvent, more solute can dissolve in it. So if the temperature of a saturated solution is lower, that is if the temperature is brought down, or if a solution is left open at a higher temperature for long, the solvent slowly vaporizes. That means it will go off, it will evaporate. Okay, so a part of the dissolved solute separates out in the form of crystals. That means, just think, children, we are making a saturated solution at a certain temperature, and you have, supposing, I will give you a simple example. You take 1 spoon of sugar, it dissolves, another spoon of sugar, it dissolves, then you take another spoon of sugar, it does not dissolve. Now you heat the water, the solution a little bit, and you stir that extra spoonful of sugar. So there you see, when it is heated, that extra spoon dissolves. Now supposing you cool the water, what will happen? The temperature of the solution will come down. So at that normal room temperature, 1 spoon of sugar did not dissolve. It had dissolved at a little bit higher temperature. So what will happen to the extra spoon of sugar that we had added by heating the solution? It will come out as crystals, because it is not required there. It does not have space. It cannot stay there. So that will come out as crystals. Okay. And the remaining solution which is there is still a saturated solution, but at a lower temperature. So I just talked about heating a saturated solution. If we heat a saturated solution, then it becomes unsaturated. More solute can be dissolved in this solution. Now, just now I gave you the example of adding that extra spoon of sugar and then heating it, and then it will dissolve. So we can make a saturated solution into an unsaturated one by adding more solvent to it or by heating it. So opposite of saturated is unsaturated. So a solution in which more of the solute can be dissolved at a given temperature is known as an unsaturated solution. Okay. Now supersaturated solution. Now when we talk about a supersaturated solution, we are talking about a solution that holds more solute than it can theoretically do at a given temperature is a supersaturated solution. Now if you take a glass of water, put sugar solution, 1 spoon, 2 spoon, 3 spoon, stir it, it dissolves. You take the 4th spoon, it does not dissolve, but suddenly something happens and that 4th spoon also dissolves, even though it was not supposed to dissolve, then that solution is known as a supersaturated solution. So when we heat a saturated solution and dissolve some more solute in it, then we cool it back to room temperature without causing any disturbance, then the resultant solution holds more solute than the saturated solution if the extra solute does not come out as crystals. Okay, so this solution is known as a supersaturated solution because it holds more solute than it can theoretically hold at that temperature. So definition is a supersaturated solution at a particular temperature is one that is more concentrated, that is, it contains more solute than its saturated solution at that temperature. Remember, temperature is very, very important. Okay, and remember that a supersaturated solution is metastable. Metastable means if you just slightly disturb it, if you shake it little bit or stir it or scratch the wall of the container or add a solute crystal to the solution, then what will happen? It will no longer remain a supersaturated solution. Now we can cool down a saturated solution. Okay, we can cool it down without the excess of solute crystallizing out. That is, whatever excess we had put in the solution by heating it. I had told you that when we cool it, that extra solute will come out as crystals, but we can keep it in the solution to turn it into a supersaturated solution. Okay, we must be careful, and we can turn it into a supersaturated solution if there are no suspended impurities like dust particles, okay, in the solution. And as I already told you, the solution must not be disturbed. It must not be shaken or scratched. The wall of the container must not be scratched. And that means the container must be left standing still. Nothing should be done. It should remain like that. And then when the temperature comes down, what will we get? We will get a supersaturated solution. Okay, children, this is all for today. In the next upload, we will continue with the concentration of solution. Now, for this week, your assignment will be to write down all the definition you come across till wherever I have done, and to write down the characteristics of a true solution and submit it on the 1st of August, that is this Saturday. Till then, children, stay safe. God bless you.